The ASTRALS project is looking at audio and video streaming, mainly in the home leisure market. So in particular, it would be looking at how we could stream high quality video around your home, particularly relevant given that we're now approaching analog TV switch off. Other partners were also very interested in, for example, security aspects, so looking at security cameras, the whole issue now of homeland security being quite an important aspect. Some of our other partners were very much interested in the video codec part of the problem, so they were looking at how best to compress the video and transmit it with low bit rates, and also how to transcode the video, which is changing the data rate from the original source rate to a rate more appropriate for transmitting over, for example, a radio system. From a university viewpoint, we need funding in order to fund our postgraduates and our research assistants in order to perform the innovative research that we are all about performing. But from the company perspective, I suspect the larger companies are not so fussed about the financial benefits of being involved in the project. They're very much about wanting to access innovation and also share their own innovative skills with other partners in order to take on a project which is far bigger than they could do on their own, or that requires expertise in areas where they're perhaps not the known experts. Certainly in the case of ASTRALS, I think this is what happened. We had several partners who were very good at building hardware or were very knowledgeable on video, but weren't so knowledgeable on wireless transmission or antenna technology or the latest developments in radio wave propagation. Really it was coming together as a consortia that allowed us to cover all of the different aspects necessary to put forward a complex prototype that could explore the ideas that as a group we all wanted to take forward. One SME, Provision, was a company formed from the University of Bristol about 7 or 8 years ago, and that company was specifically interested in video codec technology. We were also in close contact with a ex-PhD student from the university who was now working for a company called I+D in Singapore. He was very keen to maintain the close collaborations back to the university. We'd also been collaborating on a PhD activity with Mitsubishi in the UK, and they have a large video lab based in the UK, and the project ideas were also looking very attractive to them. We then started looking to find other partners that could join the consortium, and we identified ST and Thomson, who were interested in home media streaming and also very interested in the usage of some new wireless technologies known as WiMAX and how that could be used to improve the quality of video distribution within a home environment. And that really was the genesis of the project idea.
When I started my PhD, we were looking about some hot topics in the wireless communication area. So back at that time, everybody was working on MIMO, and probably most people down the lab still are working on it because it's a very interesting topic. So we were looking around about what things we can improve on existing MIMO systems.
The MIMO technology, which is used in parts of ASTRALS, is a technology that's I guess starting to become more mainstream in that it's coming through into products that we can go and buy in the shops. Fundamentally, it uses more than one antenna on the transmitter and more than one antenna on the receiver. So within the context of ASTRALS, we were very keen to exploit the MIMO technology to improve data rates because we wanted to transmit high definition video, which is now become very important to any home media streaming product. The problem is that when we used the MIMO technology that was in the literature, that was known, then the system failed in line of sight. So if you were in the same room as the set-top box, you couldn't get the system to work reliably. So this was a key challenge that we needed to address. And luckily this was an area that the university and Mitsubishi had been working on previously through a PhD program. And so we had already had some good ideas of how to solve the problem. In fact, it had gone as far as filing a patent on a particular technique to overcome the deficiency by modifying the way in which we actually exploit the MIMO through the antennas.
You cannot patent the mathematics, but what you can patent is an antenna design based on some principles which are given by the mathematics. So the mathematics are used to design specific antenna arrays, that the antenna arrays can be patentable.
The results are being, exploited by a number of the major partners. If we take Mitsubishi, for example, their labs now in the UK are looking to exploit this technology. And STMicroelcrtonics have labs in Italy and also in Bristol. And again, the set-top box activity is something which is very UK-centric for their activities. Also, the spin-out company Provision that was involved in the ASTRALS project is currently developing a number of product offerings based on some of the ideas that were actually developed and refined within the ASTRALS program. I mean, each partner has an exploitation plan for their part of the activity, and if other partners' work or collaboration with other partners becomes more valuable, then that may actually trigger a whole new exploitations and products that were never envisaged at the start. And in actual fact, that's quite common, that you'll end up developing a range of products at the end of your program that are completely different to those that you thought about at the start of your program.